somewhere in northern France, August 1944. The column had been moving since before dawn. 31 trucks, most of them gray-green, stenciled with the Balkenkreuz on their doors, rolling west on a road that 3 weeks ago had been a German supply route. Now it was American. The man walking alongside the lead vehicle was Captain Gerald F. Brubaker, 29 years old. Before the war, he had been a mechanical engineer at the Mack Trucks plant in Allentown, Pennsylvania, and before that, he had spent 2 years at Lehigh University studying load tolerances and drivetrain dynamics. He wore no decorations worth mentioning. He was not a combat officer. He carried a clipboard. The trucks he was supervising had been German property until roughly 72 hours ago. Opel Blitz models mostly, the 3.6-liter six-cylinder workhorses that had carried Wehrmacht supplies from Normandy to the Eastern Front and back again. Several of them still had German registration plates. One still had a Wehrmacht field kitchen bolted to its cargo bed. What Brubaker had done to these vehicles in the past 3 days was not dramatic. It was methodical. It was the kind of work that never appears in battle histories and never earns a medal. But it was the reason those 31 trucks were now rolling in the opposite direction, carrying American ammunition, American rations, American fuel, toward the front lines of the Allied advance. The question nobody was asking loudly enough in August of 1944 or in the decades since is how. How did American technical units turn an enemy logistics fleet into their own in 72 hours, with field tools, partial documentation, and almost no German language expertise? How did they do it fast enough to matter during one of the most fluid operational moments of the entire European war? And why did it work as well as it did? Well enough that captured German vehicles eventually made up a measurable fraction of American transport capacity during the breakout from Normandy. To understand what Brubaker and his colleagues figured out on the roads of France, and why the answer to that question reaches back to decisions made in Detroit and Washington years before the first shot was fired, we need to start somewhere most people never look. We need to start with the problem of the other man's machine. Часть первая. The problem of the other man's machine. There is a thing that happens when an army captures enemy equipment at scale, and it almost never goes the way the capturing army expects. The assumption, reasonable on its face, is that a truck is a truck. 4 wheels, an engine, a cargo bed. You climb in, you drive it, you use it. Armies throughout history have operated on some version of this assumption, and throughout history, it has caused them varying degrees of grief. The Wehrmacht itself was a perfect illustration of the problem. By the summer of 1942, German forces on the Eastern Front were operating a vehicle fleet that included equipment from at least 15 different countries: French Renaults, Czech Tatra lorries, captured Soviet trucks, British vehicles taken in North Africa, and their own expanding domestic production. The German quartermaster staff had a word for this: Typenvielfalt, type proliferation. And they considered it one of the most serious logistical problems on the Eastern Front. Spare parts were incompatible. Mechanics trained on one vehicle were useless on another. Maintenance cycles diverged. By the winter of 1942, the Wehrmacht's own internal studies estimated that type proliferation was contributing to vehicle availability rates as low as 35% in some transport units, meaning that on any given day, nearly 2 out of every 3 vehicles in certain German columns were deadlined, waiting for parts or expertise that didn't exist. The Americans knew about this problem. They knew about it not because they had studied the Wehrmacht specifically, but because the United States Army Ordnance Corps had been studying it in general since the 1930s, when a series of internal reports began documenting the maintenance chaos that followed every large-scale vehicle capture in military history. The man most responsible for translating that knowledge into a practical doctrine was Brigadier General Levin H. Campbell, Jr., who became Chief of Ordnance in August of 1942 at the age of 53. Campbell was a West Point graduate, class of 1909, who had spent the interwar years obsessing over what he called the maintenance tale. The infrastructure of spare parts, trained mechanics, and standardized procedures that determined whether a vehicle fleet actually worked or merely existed on paper. He had watched the chaos of World War I, in which the American Expeditionary Forces arrived in France with vehicles that couldn't be maintained because nobody had thought to ship the right tools. He was determined not to repeat it. Campbell's core insight, which he pushed through the ordnance bureaucracy with considerable force between 1942 and 1943, was this. The ability to use captured enemy equipment was not an accident of war. It was a capability you could design for in advance. You could train for it. You could build the tools for it. You could write the manuals for it, even if you had to write those manuals before you knew exactly which enemy equipment you were going to capture. This was a genuinely radical idea in 1942. Most military planning treated captured equipment as a windfall bonus, nice when it happened, impossible to predict, not worth planning around. Campbell argued the opposite. He argued that in a war of the scale the United States was about to fight, captured equipment would be a logistical resource of strategic importance, and treating it as an afterthought was a form of waste the Army could not afford. He was right, but the machinery to act on his insight took time to build. The first concrete product of Campbell's push was a series of what the Ordnance Corps called Enemy Equipment Intelligence Teams, small units of engineers and mechanics whose job was not to fight, but to examine. When Allied forces captured a German vehicle, an artillery piece, a tank, or a radio set, these teams were supposed to get to it quickly, document it, and produce reports that would feed back into the training pipeline. The teams began forming in 1942 and were deployed in North Africa beginning in early 1943. North Africa was, in retrospect, the laboratory. The Africa Corps had left behind a significant quantity of German and Italian vehicles when Rommel's forces were pushed back, and the American and British forces that captured them faced exactly the problem Campbell had predicted. The vehicles were there. The expertise to use them was not. Mechanics who had trained exclusively on American equipment stared at German carburetors and Italian fuel systems with the particular blankness of a man who knows what he's looking at in general terms, but has no idea what to do with it specifically. What the enemy equipment intelligence teams found in Tunisia and Libya was simultaneously encouraging and alarming. Encouraging because German vehicles, particularly the Opel Blitz and the larger Mercedes-Benz L4500, turned out to be mechanically more accessible than expected. The engineering was not exotic. The tolerances were different, the fittings were metric rather than imperial, the ignition systems had some quirks, but a competent mechanic who knew what he was looking for could work on these vehicles without speaking a word of German. Alarming because almost none of the mechanics in American units knew what they were looking for. The gap was not intelligence, it was documentation. The ordnance teams began writing. Through 1943 and into early 1944, a small group of engineers and technical writers, working out of offices in Washington and in forward areas in North Africa and later Italy, produced a series of documents that had no precedent in American military history. They were maintenance manuals for vehicles the United States Army did not own, written in English, calibrated to the skill level of an American mechanic with standard tools, and designed to be used under field conditions with no other reference material available. The most important of these documents, for the campaign that was about to unfold in France, was Technical Manual TM-E9-803. Its official title was German motor vehicles. Its unofficial nickname among the mechanics who used it was simply the German Book. Hold that title in your mind. We'll come back to it. By the time the Allied forces landed in Normandy on the 6th of June, 1944, the American Ordnance Corps had been preparing for the captured vehicle problem for nearly 2 years. The preparation was imperfect, incomplete, and in some ways still deeply inadequate. But it existed. And in the chaos of the Normandy breakout, existence was enough to make a difference. The book, the metric wrench, and the man who wrote neither. The thing about TM-E9803 is that it should not have been possible to write it. Technical manuals for military vehicles are produced by the manufacturer, working with the military customer, over months or years of testing, with full access to engineering drawings, tolerances, and the engineers who designed the vehicle. The American Army's standard manuals for the Jeep, the 2.5-ton GMCCCWK truck, and the M4 Sherman tank ran to hundreds of pages and represented thousands of man-hours of work by people who had complete information. The team that produced TM-E9803 had none of that. They had captured vehicles, captured documents, many of them incomplete or damaged, and a group of engineers who were working from examination rather than design knowledge. They had, in some cases, German language manuals that had been recovered from abandoned vehicles or taken from prisoners. But translating a German military maintenance manual into English is not a simple task. The vocabulary is specialized, the conventions are different, and a mistranslation in a torque specification or a fuel mixture ratio is not an abstract error. It is the kind of error that destroys an engine. The man most responsible for the practical content of the German vehicle manuals was not a general or a famous engineer. He was a 34-year-old civilian technical writer named Harold B. Strickland from Columbus, Ohio, who had spent the previous 8 years writing maintenance documentation for International Harvester's Commercial Truck Division. Strickland was not in uniform. He was a War Department contractor working under the Ordnance Corps, and his name appears in almost none of the histories of the Normandy campaign. Think about what that means. The document that would eventually allow American mechanics to keep 31 German trucks rolling through northern France in August of 1944 was written by a man from Ohio who had never been to Germany, based on vehicles that his team had to disassemble and reassemble to understand, working against a deadline they couldn't fully predict because nobody knew when the invasion of France was going to happen or what it was going to capture. Strickland's approach, according to the internal ordnance correspondence that survives in the National Archives, was to build the manual around what he called the diagnostic entry point, the moment when a mechanic encounters a problem and needs to identify it. Rather than organizing the manual around the vehicle's systems in sequence, engine, then transmission, then fuel, then electrical, Strickland organized it around symptoms. The engine won't start. The transmission slips under load. The vehicle pulls to one side. Each symptom led the mechanic through a decision tree that ended at the specific component, the specific procedure, and the specific specification. This was not how American military maintenance manuals were written in 1943. It was, in some ways, ahead of its time. The manual also addressed a problem that seems obvious in retrospect, but had apparently not been thought through in advance: the metric system. German vehicles were built to metric specifications. American mechanics worked in inches and pounds. A torque wrench calibrated in foot-pounds is not directly useful when the specification calls for a value in Newton meters, and a mechanic under field conditions does not have time to do the conversion arithmetic in his head. Strickland's solution was a conversion table embedded directly in the manual, printed on the inside front cover, and cross-referenced in every section where metric specifications appeared. It was a small thing. It mattered enormously. The other document problem was parts identification. When an American mechanic needed a part for a GM-CCCW, he consulted a parts catalog with American part numbers, ordered through an American supply chain. When he needed a part for a captured Opel Blitz, the part number system was German, the supply chain didn't exist, and the standard American requisition forms had no field for a Wehrmacht stock number. The Ordnance Corps' solution to this was elegant in concept and chaotic in practice. They created a cross-reference system, a set of tables that mapped German part numbers to the nearest American equivalent, where one existed, and flagged the cases where no American equivalent existed and the part would have to be fabricated or cannibalized from another captured vehicle. The cross-reference system worked better than anyone had a right to expect, for a reason that was not immediately obvious. German truck engineering in the early 1940s drew heavily on American automotive technology. The Opel Blitz, in particular, had significant design heritage from General Motors. Opel had been a GM subsidiary since 1929, and while the wartime Blitz was not simply an American truck with German markings, its basic architecture reflected the same engineering philosophy that had produced the GM-CCC-WK. Several of the Blitz's components were close enough to American equivalents that a mechanic with the cross-reference guide could substitute American parts without meaningful performance degradation. Stop and think about that for a moment. The German Army's standard cargo truck was partly a descendant of American automotive engineering, which meant that the American Army's ability to maintain captured German trucks was in part a function of American companies having sold their technology to a German firm in the 1920s. The war had produced a situation in which the United States was, in a very precise sense, maintaining vehicles that existed because of American industry, just not in the way American industry had intended. Now meet the man who had to make all of this work in the field, Staff Sergeant Raymond J. Kowalski, 26 years old, from Hamtramck, Michigan, the working-class Detroit suburb that was almost entirely Polish-American and almost entirely connected one way or another to the automobile industry. Before the war, Kowalski had been a line mechanic at the Dodge Main plant, working on the assembly of commercial trucks. He had been drafted in 1942, trained as an ordnance mechanic, and assigned to the 501st Ordnance Heavy Maintenance Company, which landed in Normandy in late June of 1944 and spent the following weeks doing exactly what its name implied: heavy maintenance on everything the Army threw at it. Kowalski's unit was one of the first American maintenance companies to receive a significant quantity of captured German vehicles for processing. The vehicles came in from collection points, staging areas behind the front lines where captured equipment was gathered, assessed for usability, and either repaired or scrapped. By mid-July of 1944, the 501st was processing between 15 and 20 German vehicles per week. Most were trucks. Some were staff cars. A few were half-tracks. Kowalski kept a notebook. It was a personal document, not an official one. A spiral-bound pad he had bought at a PX before shipping out, in which he recorded his observations about the vehicles he worked on in a cramped, precise hand. The notebook survived the war and is now in the collection of the National Automobile Museum in Reno, Nevada. It is not famous. It is not cited in campaign histories. But it is one of the most detailed primary sources available on what it actually felt like to maintain German vehicles in the field. His entry for the 22nd of July, 1944, reads in part, "Opel 3-ton, engine seized. Coolant system had been drained wrong. Somebody let the drain plug thread strip and then left it. German book says to pull the head and check for warping before you assume the worst. Did that. Head was fine. Problem was in the water pump impeller, which had a crack I couldn't see until I had it in my hands. Cross-reference says the impeller is close to the one on the Dodge D-Series. It's not close enough. had to machine a new one. That last sentence, read it again, had to machine a new one. Kowalski was not a machinist by trade. He had the portable lathe that his unit carried as standard equipment, and he had the Ordnance Corps' field machining manual, and he had the dimensions of the original impeller in front of him, and he made a part that didn't exist in any American supply catalog. In a field somewhere in Normandy, with a truck he had been working on for 6 hours, and then the truck worked. This was not unusual. It was Tuesday. The scale of the captured vehicle problem in Normandy was larger than most accounts acknowledge. By the end of July 1944, 1 month after D-Day, American forces had captured or recovered an estimated 4,200 German wheeled vehicles in the Normandy lodgement area. Not all of them were serviceable. Not all of them were worth repairing. But the Ordnance Corps' own records suggest that approximately 1,600 of those vehicles, roughly 38%, were repaired and placed into American service within 60 days of capture. 1,600 vehicles in 60 days, under field conditions. The figure matters because of what was happening simultaneously on the American side of the logistics equation. The Normandy campaign was consuming American transport capacity at a rate that had not been fully anticipated in the planning. The famous Red Ball Express, the truck convoy system that would eventually move an estimated 12,500 tons of supplies per day to the advancing Allied armies, was not yet fully operational. The American First Army was short of trucks. The shortfall was real, it was measured, and it was affecting operational tempo. Those 1,600 German vehicles were not a footnote. They were a supplement to a system under strain. Часть третья. The breakout and the inventory. On the 25th of July, 1944, the United States Army launched Operation Cobra, the breakthrough operation that would crack open the German lines west of Saint-Lô and transform the static, grinding Normandy campaign into the fluid, fast-moving advance that the Allied planners had always hoped for but had largely failed to achieve in the previous 7 weeks. Cobra worked. Faster than almost anyone predicted. Within 72 hours of the initial bombardment, the German 7th Army's front had collapsed across a width of roughly 40 kilometers. American armored columns were moving south and then west, cutting behind the German positions in a movement that would eventually encircle the bulk of 2 German armies in what became known as the Falaise Pocket. The speed was intoxicating, and it immediately created a problem that speed always creates in warfare. The supply lines couldn't keep up. The further American forces advanced, the longer the supply lines became. The longer the supply lines became, the more trucks were needed to keep them running. The more trucks were needed, the more the existing shortfall bit. By early August, American logistics officers were reporting that some forward units were operating with as little as 1 day's supply of fuel and ammunition on hand, a margin that, in a fast-moving armored advance, is not a margin at all. This is the context in which the captured German vehicle program stopped being a useful supplement and started being something closer to essential. The German retreat through France was disorderly in a way that left enormous quantities of equipment on the roads. This was not simply a matter of vehicles being abandoned by fleeing soldiers, though that happened. It was also a function of the Luftwaffe's near total absence from the skies over France, which meant that American tactical aircraft, P-47s and P-38s, flying in the cab rank system developed by IX Tactical Air Command, could attack German columns on the roads in daylight with near impunity. German vehicles were destroyed, damaged, and abandoned in numbers that overwhelmed the Wehrmacht's own recovery capability. The Americans moved through the wreckage. What they found was not random. The German logistical infrastructure in France had been built around a relatively small number of standard vehicle types, and the most common of these, the Opel Blitz 3-ton cargo truck, was exactly the vehicle that the Ordnance Corps had been preparing to maintain since Tunisia. The Blitz was everywhere. It had been the Wehrmacht's primary cargo hauler since 1937, with production totaling approximately 70,000 units by 1944. It was reliable, it was simple, and it was, as Kowalski had noted in his Normandy notebook, broadly maintainable by a mechanic with the right documentation and a willingness to improvise. The other common type was the larger Mercedes-Benz L4500, a 4.5-ton truck that had been the Wehrmacht's heavy cargo standard since 1940. The L4500 was a more demanding maintenance proposition than the Blitz. Its diesel engine was less forgiving of improvised parts, its electrical system was more complex, and the cross-reference tables in the ordnance manuals were less comprehensive for it than for the Opel. But it was also a more capable vehicle. It could carry more, it could handle worse roads, and in the logistical calculus of August 1944, capability mattered more than ease of maintenance. Now here is the key detail, and it is one that almost nobody writing about Normandy logistics has looked at directly. The American Army's standard cargo truck, the GMCCCWK 2.5-ton, was exactly that, a 2.5-ton truck. The Opel Blitz was a 3-ton truck. The Mercedes L4500 was a 4.5-ton truck, which meant that a repaired German vehicle was not merely an equivalent substitute for a missing American one. In terms of cargo capacity, it was an upgrade. One American CCKW could carry approximately 2.5 tons of cargo. One repaired Opel Blitz could carry 3 tons. One repaired Mercedes L4500 could carry 4.5 tons. The arithmetic, multiplied across hundreds of captured and repaired vehicles, was not trivial. The ordnance teams processing vehicles during the breakout were working under conditions that bore little resemblance to the orderly procedures described in the manuals. The collection points were overwhelmed. Vehicles were coming in faster than they could be assessed. The standard procedure: examine the vehicle, consult the cross-reference, order or fabricate required parts, complete maintenance, test, and release to service, compressed under operational pressure into something more like, does it run? Can we make it run? How quickly can we make it run? This is where individual competence became decisive, and where the Ordnance Corps' pre-invasion training paid its most direct dividend. The mechanics who had been trained on the German vehicle program, who had worked through the manuals, who had practiced on captured vehicles in England before the invasion, who had the cross-reference tables memorized or at least familiar, could triage a damaged German vehicle in a fraction of the time it took an untrained mechanic. They knew what to look for. They knew which problems were fixable in the field and which required a full workshop. They knew which German parts had American equivalents and which didn't. That knowledge, accumulated over months of preparation, translated directly into throughput, into more vehicles repaired per day, per unit, per hour of available labor. Meet one more man, Second Lieutenant Thomas A. Ferraro, 23 years old, from Newark, New Jersey, where his father ran an auto repair shop on Bloomfield Avenue. Ferraro had grown up under cars. He had been accepted to the engineering program at Rutgers University in the autumn of 1941, attended for exactly 1 semester, and been drafted in February of 1942. He trained as an ordnance officer, proved sufficiently capable that he was sent to the Ordnance School at Aberdeen Proving Ground in Maryland for advanced training in foreign vehicle maintenance, and landed in France in July of 1944 as a platoon leader in a medium maintenance company attached to the Third Army. Ferraro wrote a report. This one was official. A monthly maintenance summary for August 1944, submitted through the Third Army Ordnance Chain of Command and now held in the records of the Army Ordnance Corps at the National Archives in College Park, Maryland. The report is 11 pages long. Most of it is tables: vehicle counts, repair hours, parts consumption, vehicle availability rates. But on page 7, Ferraro wrote a paragraph that is worth quoting in full because it captures something about the captured vehicle program that the tables don't. The German vehicles processed by this platoon during the period under report have in general proved more serviceable than anticipated. The Opel 3-ton in particular presents no extraordinary maintenance challenges for trained personnel. The principal difficulties encountered are, first, parts availability for components without American equivalents, which requires fabrication or cannibalization and adds significantly to repair time. Second, fuel system compatibility, as the German vehicles in this category are calibrated for fuel specifications that differ slightly from standard American issue, and performance degradation has been noted in approximately 30% of vehicles after extended operation on American fuel. And third, driver unfamiliarity, which has resulted in a number of preventable mechanical failures attributable to incorrect gear selection and improper clutch operation by American drivers not accustomed to German transmission characteristics. Read that third point again: driver unfamiliarity. The mechanics had been trained, the manuals existed, the parts cross-references had been worked out, but nobody had fully addressed the problem of teaching American truck drivers to drive German trucks. The transmission characteristics of the Opel Blitz were different from the CCKW in ways that were not dramatic but were consequential. The clutch engagement point was different. The gear ratios were different. The braking behavior under load was different. American drivers who climbed into a Blitz and treated it like a CCKW were, according to Ferraro's report, burning out clutches and stripping gears at a rate that was consuming a meaningful fraction of his unit's repair capacity. The Army's response to this problem was, characteristically, a manual. By September of 1944, the Ordnance Corps had produced a 2-page driver orientation guide for the Opel Blitz and a similar document for the Mercedes L4500. The guides were printed on cardstock, laminated where possible, and attached to the steering columns of captured vehicles placed into American service. They covered the key differences from American practice in plain language, with diagrams. 2 pages, laminated to the steering column. This was not a sophisticated solution. It worked anyway. Часть 4. The forensic verdict. Here is the forensic verdict of this investigation. The American Army's ability to turn captured German trucks into operational American transport during the Normandy campaign was not luck. It was not improvisation in the heroic sense that the word usually implies in war stories. It was the product of a specific, deliberate, multi-year preparation program that had been designed precisely for this purpose, executed imperfectly but adequately, and deployed in circumstances that tested its limits without breaking it. Let's count what that preparation actually involved. The enemy equipment intelligence teams that began forming in 1942 and deployed to North Africa in 1943 represented the first systematic American effort to build an organic capability for captured vehicle maintenance. They produced the documentation base, the vehicle assessments, the parts analyses, the system descriptions that fed directly into TM-E9803 and its companion manuals. The manuals themselves represented an engineering achievement that is easy to undervalue because they were successful. Writing a maintenance manual for vehicles you don't own, in a language different from the language in which they were designed, calibrated to the skill level of mechanics who have never seen the vehicles, and organized around the diagnostic realities of field maintenance rather than the theoretical sequence of the engineering, this was not a trivial undertaking. Harold Strickland and the team at the Ordnance Technical Writing Office in Washington did something genuinely difficult. and they did it well enough that it worked under the most demanding possible test conditions. The metric conversion tables, the cross-reference parts catalogs, the driver orientation cards laminated to the steering columns. These were small things. Together, they represented a system. Now consider what the system actually achieved. By the end of September 1944, 3 months after D-Day, the American Ordnance Corps had processed and placed into service an estimated 2,800 German wheeled vehicles in the European theater of operations. The majority were cargo trucks. Using the capacity figures from the German vehicle types involved, those 2,800 vehicles represented a total cargo capacity of approximately 8,500 tons per convoy cycle, equivalent to roughly 3,400 American CCKW trucks. 3,400 trucks. That is not a footnote. That is a transport regiment. Now for the honest accounting. Because this investigation would not be complete without it. The program had real failures, and they matter. The fuel compatibility problem that Ferraro identified in his August report was never fully solved in the European theater. German diesel vehicles operating on American diesel fuel showed performance degradation that, in some cases, shortened engine life significantly. The Ordnance Corps produced additive recommendations and adjusted fuel blending guidance, but these solutions were partial. Some captured vehicles that might have served for a full campaign were worn out faster than they should have been because of fuel chemistry that nobody had fully worked out in advance. The parts fabrication burden was real and was never adequately addressed. Kowalski's experience of machining a water pump impeller in a field in Normandy was repeated, in various forms, thousands of times across the theater. The portable machine tools that ordnance units carried were excellent for their purpose. But fabricating parts takes time, and time under operational pressure is the one resource that cannot be manufactured. The cross-reference catalogs covered the most common components but left significant gaps, particularly for the heavier German vehicle types. The driver training problem was addressed late and inadequately. The laminated steering column cards were a practical stopgap, not a training solution. The clutch and transmission failures that Ferraro documented in August were still occurring in October, at a lower rate but still at a rate that represented preventable mechanical wear. A more systematic driver orientation program integrated into the vehicle processing pipeline at the collection points would have saved repair hours and extended vehicle service lives. The Ordnance Corps knew this. It did not have the resources to implement it fully, and there is a deeper structural problem that the program never solved, and that deserves to be stated plainly. The captured vehicle program worked in Normandy and in the subsequent advance across France because the German vehicles being captured were, by the standards of 1944 military engineering, relatively conventional. The Opel Blitz was a straightforward, well-built truck. The Mercedes L4500 was more demanding but not exotic. The Ordnance Corps' preparation had been calibrated to exactly these vehicle types, because they were the ones the intelligence teams had studied in North Africa. If the Wehrmacht had been fielding significantly different vehicles, if the German logistics fleet had been built around diesel-electric hybrids, or around vehicles with fundamentally different drive architectures, or around types that had no American engineering heritage, the cross-reference system would have been far less useful and the repair rates would have been far lower. The success of the program was, in part, a function of the particular history of German-American automotive technology transfer in the 1920s and 30s. Opel and GM. The German automotive industry's adoption of American mass production methods. The fact that a German truck and an American truck in 1944 were built from the same fundamental engineering tradition, even if the specific implementations differed. This was not something the Ordnance Corps had designed. It was something they had been fortunate enough to inherit. Hold that thought. We'll come back to it. What happened to the people in this story? Levin H. Campbell Jr. served as Chief of Ordnance until 1945 and retired as a full general. He died in March of 1976 at the age of 86 in Washington, D.C. His memoir, published in 1954, devotes exactly 2 paragraphs to the captured vehicle program. He considered it a minor success in a larger story. He was probably right about the proportions, but not about the significance. Harold Strickland returned to International Harvester after the war and spent the remainder of his career writing maintenance documentation for commercial trucks. He retired in 1971. He is not in any military history. The manual he wrote is in the National Archives, and copies of it are occasionally sold at militaria auctions for between $40 and $120. Raymond Kowalski came home to Hamtramck in the autumn of 1945. He went back to Dodge, Maine, worked on the line for 2 more years, and then opened his own repair shop on Conant Avenue, which he ran until 1983. His notebook is in Reno. He died in 1991 at the age of 73. His obituary in the Detroit Free Press described him as a veteran and a local businessman. It did not mention the Opel Blitz. Thomas Ferraro finished the war as a first lieutenant, went back to Rutgers on the GI Bill, completed his engineering degree in 1948, and spent 30 years as a manufacturing engineer at Ford. He died in 2004. His maintenance report from August 1944 is in the National Archives. It has been cited in exactly 2 academic papers. Gerald Brubaker, the man walking alongside the lead vehicle at the beginning of this story, with his clipboard and his 31 German trucks, returned to Mack Trucks in Allentown after the war and eventually rose to become a senior engineer in the company's commercial vehicle division. He died in 1989. If he wrote a memoir, it has not been found. Now come back to the road in northern France, August 1944. Brubaker is walking alongside the lead truck, the Balkenkreuz on the door, the Wehrmacht field kitchen still bolted to the cargo bed of the vehicle 3 places back. 31 trucks rolling west, carrying American supplies. What made that column possible was not a battle. It was a manual written by a man from Ohio who had never been to Germany. It was a metric conversion table on the inside front cover of a document that nobody famous ever read. It was a spiral notebook kept by a mechanic from Hamtramck who would go home and open a repair shop and whose obituary would not mention the trucks. It was a maintenance report from a kid from Newark who had grown up under cars on Bloomfield Avenue and who had learned, at Aberdeen Proving Ground, to think about German engineering the way a diagnostician thinks about a patient, starting with the symptom, working toward the cause. The German army built those trucks. The American army captured them. And a group of engineers and mechanics, who have been almost entirely forgotten, turned them around in 72 hours. That is what preparation looks like when it works. Not a dramatic moment, not a decisive battle. A clipboard, a manual, a machined impeller, a laminated card on a steering column. The trucks rolled west. If this investigation gave you something you didn't have before, a clearer picture of what logistics actually looked like in the summer of 1944, not the version with the famous generals and the dramatic advances, but the version with the maintenance reports and the metric wrenches and the men whose names are in the National Archives and nowhere else. Press the like button. It keeps this kind of history visible a little longer. And it deserves to be visible. The German army spent years building the Opel Blitz into the backbone of its logistics in France. The American army spent 2 years preparing to use it against them. The preparation was quiet, unglamorous, and almost entirely successful. The trucks rolled west. The men who made that happen never got a parade. They deserved one.